All right, so today we're going to pull back the curtain on something amazing, the invisible architecture that keeps our entire digital world from just falling apart. It's the hidden rulebook, the unseen order that makes everything work so seamlessly.
So let's just start with this question. I mean, seriously, think about it. 10,000 devices. How on earth does that not turn into a complete nightmare? Well, behind every single one of those perfect connections, there is a super detailed plan. It's not magic, not at all. It's just really, really good engineering.
And it all starts right here. Not with plugging in a cable, but with documents. You gotta have the blueprints, the architect's plan, before you even think about putting the first piece of hardware in place.
Now, what you're looking at here is pretty cool. Every network needs two different kinds of maps to make any sense. On the one hand, you've got the physical diagram. That's the literal roadmap. It shows you where every wire goes. But then you have the logical diagram, and that shows you how the data itself is flowing, the path the information takes. You absolutely have to have both to get the full picture.
And believe me, it goes way deeper than just a couple of diagrams. A complete blueprint has a full asset inventory, which is just a massive list of every single piece of gear. It's got cable maps and even a wireless survey, which is literally a heat map showing you exactly how strong the Wi-Fi signal is in every single corner of the building. Pretty wild, right?
And this is how they keep it all straight. It's called IP address management, or IPAM for short. Just think of it like the network's official address book. Its whole job is to make sure that no two devices ever try to claim the same digital address. Because if they did, it would be like two houses having the same street number. Just total chaos.
Okay, so we've got the plans. They're all on paper. Now what? Let's move on and see how this super detailed blueprint actually comes to life as a physical thing, made of steel, copper, and fiber optics.
So, in any big building, the network has to have a central nerve center, right? That's what we call the main distribution frame, or MDF. You can think of it as the main post office for the whole operation. From there, all the connections run out to these smaller hubs, the intermediate distribution frames, or IDFs, which are kind of like the local meal rooms for each department or floor.
And when you get inside those network rooms, oh man, the organization gets even more specific. A rack diagram is this incredibly precise schematic that shows you exactly where every single server, every switch, and every power supply is supposed to live inside its metal cabinet. There is absolutely zero guesswork involved here. These are the actual physical spots where the plan finally meets the cables. You've got patch panels for all the standard copper wiring, and then fiber distribution panels for, well, the fiber optics. It keeps everything neat and organized. And of course, these racks are lockable. That's a huge deal because physical security is every bit as important as digital security. But, building a really solid network, that's just the beginning. The real challenge is keeping it healthy and secure over years and years of constant use. That's the hard part. See, every single piece of equipment has its own life story, its own planned journey. It starts with deployment, day one. Then it heads towards its end of support date. That's when the manufacturer stops helping you with it. After that comes end of life, when it's officially obsolete. And the final step is decommissioning. It's scheduled safe retirement. This whole cycle is crucial for making sure old, vulnerable gear doesn't hang around causing problems.
And just like the hardware, the software needs constant attention. It's just like your phone, right? You're always getting updates. For networks, this means installing patches for security holes, doing big operating system updates, and even upgrading the firmware. That's the deep down code that makes the hardware actually run. It's a never-ending cycle of maintenance.
Okay, so this is a really important point. Network health isn't just some vague idea. It's a formal promise. It's a contract. And it's called a Service Level Agreement, or SLA. This thing legally guarantees a certain level of performance and uptime, like the network will be up 99.999% of the time, and if that promise is broken, there are penalties.
So, if everything is so perfectly planned and documented, what happens when you need to change something? I mean, you can't just go in there and unplug a cable and, hope for the best.
No way. You have to follow a really strict formal process called change management. Any change, no matter how small, starts with a formal request. Then it goes through an approval process to figure out all the risks. Then it gets scheduled for a time that's going to cause the least disruption, like maybe 3 a.m. on a Sunday. And finally, after the change is done, it gets fully documented. This whole process is what prevents one tiny little tweak from accidentally taking the entire company offline.
Now, part of managing all this change safely means you're basically juggling 3 different versions of the network settings.
You've got the production version, that's what's live right now. You have a backup, a safe copy you can roll back to if everything goes wrong. And then you have a baseline or a golden configuration. That's the perfect, pristine template you use to build any new devices.
So when you put all of this together, the diagrams, the inventories, the changelogs, all of it, you start to realize something. This isn't just a big pile of paperwork. It's the network's memory. It's the only thing that remembers why a decision was made 5 years ago, or how something was built, or what's supposed to be plugged in where.
And that really leaves us with one last big question. If all this documentation is the brain that keeps the network alive and sane, what are the real-world consequences when a company gets amnesia? What happens when the people who built it are long gone, and the blueprints are lost forever?